Here are 3 points. They appear to be all lined up. And they are. They all lie on the same line. Points that lie on the same line are collinear. Here are 3 more points. They do not appear to be lined up. Points that do not lie on the same line are non-collinear. For our collinear points, we say that point K is between points J and L. For our non-collinear points, we're not able to say that point T is between points S and U. For a point to be between 2 other points, it must be collinear with those 2 points. For any set of 3 points, there are 2 possibilities. The points are collinear, or the points are non-collinear. 3 segments can be determined from any set of 3 points, and in this case, the segments are JK, KL, and JL. The length of the longest segment, in this case JL, will be equal to the sum of the lengths of the other 2 segments. Let's get our ruler out and show that. J to K is 5.2 centimeters, K to L is 2.8 centimeters, and J to L is 8.0 centimeters. And if we add 5.2 plus 2.8, we get 8.0. Any 3 non-collinear points determine a triangle. And here it is. The 3 segments determined by these 3 points are the sides of the triangle. The sum of the lengths of any 2 sides of a triangle is greater than the length of the third side. And this is known as the triangle inequality. Well, let's demonstrate it. I've moved the triangle over to the upper right, and I've pulled out the 3 sides which now appear on the left as segments. But I've kept them the same length. Well, it's obvious that the long one, SU, plus either one of the other 2 is going to be longer than the third one. But the demonstration needs to show that the 2 shorter ones, ST and TU, when added together are longer than SU. So we'll move them down and line them up, and there they are. And clearly, ST plus TU is longer than SU. Here's a diagram. If you're working on a complete course in geometry, you'll look at a lot of diagrams. And here's what we may assume when looking at a diagram. We can assume straight lines, segments, and rays. And in this diagram, we have several segments. I count 4. And the 4 segments come from lines VW, WY, VX, and YZ. We can also assume angles. I count 8. Let's take a look at them one at a time. There's an angle with vertex at V, another angle with vertex at W, another one with the vertex Y, and another angle vertex Z, and there's 4 angles that could have vertex X, so we'll use the 3-letter method to distinguish. There's angle VXW, there's angle WXZ, there's VXY, and finally YXZ. So if it looks like a straight line or an angle in a diagram, we can assume that it is. We can also assume collinearity of points. So in this diagram, we can assume that V, X, and Z are all collinear, and W, X, and Y are all collinear. We can also assume betweenness of points. So for this diagram, we get to assume that point X is between V and Z, and point X is also between W and Y. And we can assume the relative positions of points. And for this diagram, here are some examples. We can assume that point X is near the center of the diagram, point V is at the upper left of our diagram, and point Z is at the lower right. And these are some examples of some assumptions we could make about relative positions of points. What we may not assume is right angles. In this diagram, there's 2 angles that look to be right angles, but they're not marked as right angles, so we're not allowed to assume that they're right angles. We're also not allowed to assume congruent segments. In this diagram, I believe X, Y, and YZ look to be the same length. But they're not marked as the same length, so we're not allowed to assume that they're the same length. We're also not allowed to assume congruent angles. The Angle with vertex V and the angle with vertex Z, to me, look to be congruent, but they're not marked as congruent, so we're not to assume that they're congruent. We also may not assume parallel lines, segments, or rays. And again, in this diagram, I believe that segment VW looks to be parallel to segment YZ. But just because they look parallel doesn't mean we can assume that they're parallel. We're also not allowed to assume relative sizes of segments and angles. Sometimes in a sketch, a segment might look longer than another and turn out to be shorter. Or an angle might look to be larger than another and turn out to have a smaller measure. Sketches are just sketches. They're not always precise. Often, when a problem is designed to be challenging, a sketch that accompanies a problem will intentionally be out of scale to make it difficult to solve. But often, sketches are inaccurate simply by accident. Most diagrams are relatively accurate, but some are not. Points that lie on the same line are collinear. Points that do not lie on the same line are non-collinear. A set of any 3 points is either collinear or non-collinear. For a point to be between two other points, it must be collinear with those 2 points. A set of any 3 points determines 3 segments. If the points are collinear, the length of the longest segment is equal to the sum of the lengths of the other 2 segments. If 3 points are non-collinear, the points determine a triangle. The sum of the lengths of any 2 sides of a triangle must be greater than the length of the third side. This is known as the triangle inequality. When looking at diagrams, we may assume straight lines and angles, collinearity of points, betweenness of points, and relative positions of points. We may not assume right angles, congruent segments, congruent angles, parallel lines, and relative sizes of segments and angles.